All right, let's do another example. Let's do water. Let's do our high quality H2O. All right. For any of you who don't know, that's a really bad atom sample. So, all right, H2O. Central atom. Well, if you read carefully, what atom can never, ever be the central atom? Hydrogen. Reason is this. Hydrogen is one of your exceptions, isn't it? It only wants 2 valence electrons. Well, here's what happens with hydrogen. You do that. Say, maybe you take the 2 hydrogens and bond them together in the middle. What's your problem? There's 1 electron here, 1 electron here, meaning that hydrogen has how many electrons?
2.
2. That hydrogen has how many electrons? 2. Are they happy right now?
Yeah.
So why the heck would they want to bond with an oxygen then? So hydrogen can't ever be in the middle because the second it bonds with another hydrogen, it's happy. So, can't be in the middle. So, I'm going to draw it wrong on purpose, okay? And as you will too, because your first drawing is usually not right. So you realize that oxygen is your middle thing, okay? And by the way, we got to do our numbers first. Let's do the numbers.
Do you want us to draw it?
Yeah, we'll draw it and then we'll fix it. Like the whole process is 2 drawings. It just is. So for hydrogen, how many valence electrons? 1. And you have 2 of them, so it's 1 plus 1. And oxygen is 6. So 1 plus 1 plus 6 is 8. So here we go. Put oxygen in the middle. Bond the 2 hydrogens to it. How many electrons did we just use up in those single bonds?
4.
1, 2, 3, 4. Now, hydrogen we just said is an exception. It's happy with 2. So, are they going to want more electrons on the outside? No, you always work outside in. So these last 4, where did they get placed then? On the central atom. So you put a lone pair, 2 there, and 2 there. Why did I put them on the top of the bottom? Oh, just to be pretty. Right? Oh, look how cute it is. Is everybody happy? Hydrogen's got 2. How many does oxygen have? Is oxygen an exception on your chart, on your sheets? No. So oxygen wants 8. Does it have 8 right now? Yes. 2, 4, 6, 8. So now all you got to ask yourself is this. Did I draw it right? And the answer, unfortunately, you're about to find out is no. We look at the central atom, which is oxygen, and we got to count our things. So, here we go. You have 1 hydrogen that is bonded. You have 2 hydrogens that is bonded. You have a 3rd thing, which is a lone pair there. You have a 4th thing, which is a lone pair there. So, you get out your handy-dandy Vsepr chart, and you look for on here where it says 4 things. Now, of those 4 things, how many of them are bonds and how many of them are lone pairs? 2 and 2. So you go on this chart and you find where it says 4, 2, 2. And the shape should have been bent. So I always write what my shape is, bent. And now I got to adjust my drawing to reflect the bent drawing that is on this chart. And so what it ends up actually looking like is this. Oxygen, lone pair, lone pair, lone pair, lone, right? So you got lone pair, then hydrogen, and then hydrogen. What is the angle of my bonds on this one? 109.5. And what is the hybridization? SP. Those are all questions I could ask you. Now, what's SP? Is that SP2?
Yeah.
Yeah, it is. Thank you. All right, pop quiz. You ready? If I would have drawn it like this, Am I wrong?
No.
Am I wrong?
No.
Yes.
Just take your head and do that. Isn't it the exact same drawing? Yeah, don't fall in love with the fact that it has to look exactly like the chart, okay? These two things, guys, are the exact same thing, okay? Now, let's talk about polarity real quick, right? I think on your sheets it says discuss polarity. This molecule, water, is said to be a polar molecule. You know what that means? It means this. Remember we said that these electrons are sharing because it's covalent bond and we have two nonmetals here? But here's the kicker on this. When we say that it's polar, that sharing, is it equal or not equal? If something is polar, it's not equal. Remember the analogy I gave yesterday was the car keys. My sister and I shared a car, but it was not equal. Who got the keys? What this means is that when these two electrons are being shared here, you know who owns them a little more? Oxygen. Okay? And these two electrons here, the oxygen also pulls them in a little tighter to him than it does to the hydrogens. So because of that, this molecule is said to be polar covalent.